Hey everybody, Chris Bryant here. Thanks for joining me for today's CCNA 200-125 quick quiz. This is also for you CCNA Bulldogs out there. I'm going to have a lab question here for you on OSPF adjacencies. And frankly, I'm going to share one of the most important real-world troubleshooting tips that I have ever used. And you could use it in real-world networking, you can use it on exam day, and you can use it in your exam prep, which is what you're dealing with right now. And we're going to see that in action here in just a moment. But first, let's get to today's question. We're going to be using this directly connected network, and you see routers 1 and 2 using serial interfaces. They're on the 10110/24 subnet. I have not done anything to, untoward here, no hidden commands, and I'll show you the commands here in just a moment as far as OSPF goes. But first, I want you to tell me, and we're using the old select all that apply here, which of these issues could cause an expected OSPF adjacency not to form? A, that the potential neighbor interfaces disagree on the dead timer setting. B, interfaces through which the adjacency should form are in different areas. C, the potential neighbor interfaces disagree on the hello timer setting. And D, the layer 2 configuration of the neighbors is incorrect. If you want a little extra time to think about that, as always, just pause the video because we're going to go straight into the answers in the lab work right now. If you've studied OSPF for a while, you see a couple of classic problems here. And if you haven't studied OSPF yet, good, this is a good chance for you to learn them, because the potential neighbor interfaces are always going to have to agree on the hello time, the dead time, and the area that they are in. So A, B, and C are all definitely potential issues. If they disagree on the hello and dead timers, you cannot get an adjacency. If they're in different areas, you cannot get an adjacency. What about this layer 2 configuration of the neighbors is incorrect? And the answer is that can cause an OSPF problem as well. And you might be thinking, wait a minute. OSPF runs at layer 3. How can layer 2 problems affect what I do at layer 3? Well, when I put it that way, the light bulb might have come on, because the troubleshooting tip I want to give you, and it's something we've just got to keep in mind, is that we're building that network, from the ground up. And in this case, we're building it first off at layer 1, right? The physical layer of the OSI model. And if our cables aren't working, if something physical is wrong, then obviously nothing above that is going to be working correctly. So then you go up to layer 2, our data link layer, and that's where we've got different encapsulation types. And if there's a problem there, though, we're going to have an issue at layer 3. There's an old saying, if mama ain't happy, nobody's happy. Well, if layer 2 ain't happy, layer 3 is not going to be happy either. And let me show you exactly what I mean by that, because here you can see on routers 1 and 2, I've got the usual router OSPF config here. Then I've got the network command under each one with the subnet and then the wildcard mask and then the area number. And let's face it, that's as simple as an OSPF config is going to get. And if we put these in and then start running show IP OSPF neighbor, well, we don't get anything, which is the total opposite of what we want. Then you're going to be staring at that for a long time trying to figure out what you did wrong. And the thing is, your problem isn't at layer 3. Maybe it's at layer 2. And we're going to get a little bonus info here, because I'm going to do a show interface serial 10 here on router 2. A little bonus info and a little bonus question. What exactly does this first line mean? This is one of those things they didn't tell me when I was studying for my CCNA. None of the books ever said, here's what a line protocol is. So I always want to make a point of telling you what a line protocol is. And the thing is, this is 2 different pieces of information in one line. The first part of this line, serial 10 is up, is referring to the physical state of the interface. So you can look at this immediately and say, okay, layer 1, I'm fine. My cables are fine, everything's good. But when you see line protocol is down, that's referring to the logical state of the interface, and that is layer 2. So when I see this line, I'm thinking, okay, physically, I don't need to check cables, I don't need to do any resetting or anything like that. But my line protocol, I've got a layer 2 issue. And we can see here, the first thing I would check with the line protocol down is to make sure you don't have an encapsulation mismatch. And here I've got HDLC, which is the default for a serial interface. And if I hop over to 1 and check out the neighboring interface, I do see serial 10 is up 0010 is up, line protocol is down. And if I look down here, I see encapsulation PPP. Well, let's go back to the diagram here. And what we're going to see is that if the line protocol is down, if there's an encapsulation mismatch, layer 2 is not working correctly, so nothing you do at layer 3 is going to work. You got to fix layer 2 before you can even worry about whether layer 3 is working properly or not. Now, I've got a couple of options here. First option is to get the right interface. Second option is how do I set this back to HDLC if that's what I want to do. I could put NCAP HDLC here. Instead, I'm going to do no NCAP PPP, just to tell you about both options. And let's give that a few seconds to cook, so to speak. And you see the line protocol is up and already, and excuse me for doing that, you already see the state change to up, and right after that we got a message about our adjacency coming up. And it's gone from loading to full. So we're looking good, but you know I'm going to run show IP anyway. I'm going to run show IP OSPF neighbor, and we see that everything looks good and we have our adjacency. Now, what about this little dash here? I think tomorrow in the next quick quiz we may just be covering that one. But again, that's your troubleshooting tip for today, and boy, you should carry that with you for the next, well, frankly, your entire career. Because that's one reason for the OSI model, frankly, is that it gives you a model for troubleshooting. You know, first check everything at layer 1, is everything fine? Then check layer 2, and then check layer 3. And that way you're not wasting your time with unnecessary troubleshooting or staring at your config until your eyeballs pop out of your head. Thanks for watching today. I'm Chris Bryant, and I will be back tomorrow with a new CCNA quick quiz for you. See you then.